All right, guys, today we're going to be doing the stretching problem. And the stretching problem says this. It says, at the bubblegum factory, lengths of gum are stretched to larger lengths by putting them through stretching machines. There are 100 stretching machines numbered 1 through 100. Machine 1 does nothing to a piece of gum. Machine 2 stretches pieces of gum to twice their original length. So, for instance, if you put a 4-inch piece of gum into machine 2, it would double it. So it would give you an 8-inch piece of gum. Machine 3 triples the length of gum, and so forth. So machine 23, for example, will stretch a piece of gum to 23 times its original length. So if you put a 1-inch piece in machine 23, it will give you a 23-inch piece. An order has come in for a piece of gum 26 inches in length. The factory has pieces of gum that are only 1 inch in length, and machine number 26 is broken. Is there any way to create a piece of gum uh, 26 inches in length by using other machines? Now, guys, today the concept of prime and composite numbers will be super important. And today we're going to figure out that every number can be made up of a bunch of different prime numbers, and we call that prime factorization. Now, what we're going to do first is we're going to think about that number 26, and I'm going to think first about the factors of 26. So I'm going to write them over to the side. So if I'm thinking about the factors of 26, I know I can make that by doing 1 times 26, and I know that I can do 2 times 13. So I'm thinking about how could I split this up without having 26? Well, one thing I could do is I could take this 1-inch piece of gum and I could make it go through machine 2, which would give me 2 inches. And then I could make this 2-inch piece of gum go through machine 13, which would give me a 26-inch piece of gum. Now you'll notice that both of the machines that I had to go to, we're going to call these necessary machines, were prime numbers. 2 is prime because it only has 2 factors, and 13 is prime because it only has 2 factors. The only machines that are going to be necessary today are going to be machines that are prime numbers because every number can be made uh, up as prime numbers multiplied together. We can make other numbers. So 2 and 13 were the only necessary machines to make it. Now, let's go down and look at our next question. Our next question is going to say, some of the machines in the factory are unnecessary because combinations of other machines could be used instead. That's kind of what we just talked about. Figure out which machines are actually unnecessary. What machines would be necessary to get to the following lengths? 15 and 36. What machines would you have to have? Now, just a hint, a lot of people, when they see 36, think automatically, well, I need machine 36. You don't need machine 36. Think about what we just said. The necessary machines are going to be our prime numbers. Think about how you could get to 36 by only using prime numbers. I'll give you a hint here. You can use a machine more than once. For example, if I wanted to start with a 1-inch, because remember we're always starting with a 1-inch piece. If I wanted to put it through machine 2, which would give me 2 inches, it would be okay to put it through machine 2 again to give myself 4 inches. You can use the same machine over and over if you need to, but remember the goal here is to start off with our 1-inch piece, put it through machines that we have to have, and get to 36. And remember, those necessary machines are going to be our prime numbers. Now, so you're looking for what are the necessary machines for 15? What are the necessary machines for 36? Now, let me explain these last two questions for you here. They sometimes can be a little confusing. Let's go to the no, let's do this one first. It says, which lengths between 1 and 100 would come out if the bubble gum went through 5 machines and all 5 machines were the lowest value necessary machines. So when we're talking about the lowest value necessary machines, we're talking about any machines that are prime numbers. So when we're looking at 1 through 100 here, I'm thinking what numbers between 1 through 100 would be possible if we used 5 different machines. Well, remember you can use the same machine over. So I'm going to give you one example. We'll see if you can find the others. So let's say I put a 1-inch machine. I got to put it through 5, but it could be the same machine 5 times. So I'm going to take a 1-inch and I'm going to put it through machine 2, which is going to give me 2 inches. I'm going to take that 2-inch piece and I'm going to put it through machine 2 again, which is going to give me 4 inches. I'm going to take that 4-inch piece and put it through machine 2 again, which is going to give me 8 inches. I'm going to put that 8-inch piece through machine 2 again, which gives me 16 inches. And I'm going to put that 16-inch piece through machine 2 again, which would give me 32. So 32 inches is one possible length between 1 and 100 that is possible here if I use 5 different machines. The question is, could you use 5 other machines and still get a length between 1 and 100? You could still use 2s, but think about what other necessary prime machines would be possible to use there. That's kind of a hint. I'll give you a hint. There is more than one way to do it. You're going to look for as many as possible. There's not as many as you would think, but there are other combinations that you could use. All right, so it takes us to the last question. This is probably the hardest, but I want you to really think about this one. It says, which lengths between 1 and 1,000 require the greatest number of necessary machines? So the goal here is to start at a 1-inch piece, and we want to figure out which machine would need, or which length would need the most machines that are necessary. In other words, prime machines. Which machine would have to go through a prime machine the most number of times? My suggestion would be look for a number that's as close to 1,000 as you could be. I'll give you a hint here. What I first tried to do was go through machine 2 as many times as possible until I got as close as I could to 1,000 without going over, and that number would require a bunch of machines. And then I tried to use some other necessary numbers, and I use 3, which is also a prime number, or maybe even 5. And you're trying to see how many times can I run it through machines before I get a number that is less than 1,000, but as close as we could get probably. So think about those 3 questions. They're really going to push your thinking about prime and composite numbers today, but I really encourage you to think about the machines that are necessary, which are going to be our prime number machines. Give this problem a shot and let's see what you can do.